So in this lecture we will see how to write Python program for creating a um, mating pool. Okay, so basically here what we'll be doing is we'll be calculating the fitness functions and then seeing the fitness, and then after seeing the fitness we'll select certain this one to make a mating pool. Okay, so this is the same program. We'll just see what the new functions we have added to this program. So this we have already seen: fitness function, pop string, decode individual, and this is new definition which we are going to write. So this new function is basically chromosome population to individual population. So basically it is converting a chromosome into individual. Okay, so what it takes here is the whole population array, all the set of individual, it will take it in form of a matrix. Okay, so all the chromosome put one beneath the other forms a matrix. Then string length will give us the idea of it gives each chromosome, each variable compose how much part of the chromosome segment. Okay, so how much length each variable takes. Okay, so that information is given in the array of string lengths, and then you have upper bound and lower bound on each of the variables. So this is operation number of upper bounds on all the variables, all the upper bounds on the variables, and the lower bounds of the variables. So before we describe this full function, we'll see how this population we have already seen in the last lecture, that how we generate the population from that population string. We'll see what is string length and upper bound and lower bound, how they are given. Okay, so if you see here, what we are assuming here is string length. For example, if I take a problem of two variables, then there will be two string lengths. So it shows 10 and 10. So variable number one it has to be coded into a string length of 10, and variable number 2 has to be coded in string length of 10. Okay, so totally the chromosome will be 20 bit long, and these are the upper bounds. So upper bound on variable number 1 is 5, and upper bound on the variable number 2 is 3. So that is in order. Again, lower bound is for variable number is -1 and 0. So this is how lower bound and upper bound is there. Population size we have already seen. You have to give a population size to generate number of population. And if you remember, we used here, this is how the population is generated. So you give a population size and it generates a population of the string length you have decided. Okay, so in the string length you give how what should be the length of the chromosome. So let's go back to that function again, and I'll try to, now you know what this population is, string length is, upper bound and lower bound, how they are described here in this program. Now I describe here, I put here a new matrix, define a new matrix which is called individual pop, because the chromosomes finally will generate, a chromosome population will generate a individual population. Okay, so from that pop matrix, which is basically chromosome population, that will be changed into a individual population, and that will be given as output. So for this, if you see, we have to first take the whole chromosome, and from that whole chromosome we will have to cut those slices, that part of slices which corresponds to variable 1, then other set of slices which correspond to variable 2 and 3, and so on. So this is basically starting indices. So in this case the indices start from 0. So this is for the range from for all the population size, full population, I have to do this. Okay, so this is the starting index, depending on, so that is always start with 0, and then it takes one chromosome at a time. So this is another for loop in J. It takes one chromosome at a time. Okay, and it makes end index. So once this end index, how it is calculated. So whatever is the starting index plus the string length will give you the end index. So that is the slice corresponding to suppose variable number 1. Okay, so in this case, if you see, it will start from 0, and the first variable had a length of 10. So 0 to 10. So first 10 will correspond to variable number, and so this is end indices. Okay, so what I do is I now calculate the chromosome segment here. So this chromosome segment is nothing but from the chromosome, full chromosome, it is basically that part that is start index to end index. So take that part of the chromosome and that will correspond to variable number 1, and you can calculate the variable value with that chromosome segment. Okay, this is the segment you have taken, and you pass on to the decode individual. We saw in the last lecture how this decode individual will take this segment and give you the uh, integer value or the variable value here for that one. And from that you also see what is the string length for variable number and number of bit for the variable number 1 here if you are going for first one. Okay, so number of bits, and then it calculates the actual decimal value from that particular variable value which is a integer value. Okay, so this formula we have already seen, a lower bound, upper bound, and this one number of bit minus 1. So this is basically calculating the decimal value of that particular uh, integer value in that particular range. Okay, and then I save that particular actual value into the individual pop. Okay, so now that is what corresponds to individual pop. So the first population, first variable, first in individual, first variable j, then first variable, uh, again individual number 2, 3, and so on. So in a row it forms an individual population containing all the variables. Similarly second one, again j1, 2, 3, 4, and so on. It goes on calculating those values, actual values, and goes on populating that individual pop. Okay, so this is what it returns finally. It is integer pop. Okay, these printf statements are put here just to check if they are working fine. Okay, so I think I can run this part first and then we'll go to the other one. Okay, so individual population, here I am creating individual population. First I have calculated the population pop. Okay, so you can also write this is for this one in a single line. I have written whole thing. So one in for one in range of 0 to pop size, do this, generate population pop string sum of string length, and it will generate a full chromosome here. Then I run this one, chromosome population to individual population, give them this value here, pop value here, string length here, which is already I have shown you, upper bounds and the lower bounds, and then it finally gives you the this one. So this is printed after function call, you get an individual pop. So I'll just run this program and we'll see where how this gives this value. Okay. So here it's running, and if you see this part, okay, what is that? After function call. Okay, so after function call, if you see, what I'm getting is the individual population. So these are whole population. If you say I have taken 50 population and each of the value of individual, so this is first individual, then the next one is second individual, third one, fourth one, fifth one, and so on, and it has decoded that particular this one to a particular um, decimal equivalent. Okay, and I think this is the process when this is this part chromosome segment it is taking and it is breaking into various parts. So if you see, its starting index j equal to 1 is the start index is 10 for j equal to 1, and n index is 20. So it is starting from 10 to 20. It will take all the values through this, and that is what you get. So this is the chromosome segment. This is the whole string. The first one above one is the chromosome segment from 10 to 20, and this is the whole string. If you say, it will be 20 this long. Okay, and that is how, and it is also giving you the full value of individual. So that is printed over here. So that is how it will work for getting the it is basically transforming those chromosomes population into a individual. Okay, so this is what this function does. Then let us come to another one in which you create a mating pool. Okay, how you create a mating pool, we'll see. Here, if you see, if you want to create a mating pool, what has to be done, should know the population, the individuals in a population. Okay, and then that population is there, string length is there, and you also know the cumulative sum. So you do the cumulative sum and you give it to the this one. So uh, beneath this, I have made arrangement to calculate the cumulative sum. Basically, if you have the fitness values put in an array, you can just go on adding one by one and put one by one below that, and you get the cumulative sum. That I will show you later on, but that is also a kind of array which contain the cumulative sums. So what this basically does is you generate a mating pool, which is you define zeros. So you have that kind of a mating pool having the same mating pool is again a chromosome pool. Okay, so it will have a same set of individual as you have in pop. So whatever is the uh, length and breadth of pop matrix, same is the length and breadth of this mating pool pop matrix, population matrix also. Now what it does basically, if you have the cumulative sum, it normally it runs for each of the individuals in the population, and I have simulated the needle which I showed you in the lecture part. It is a random value is generated, that is the needle, and that random value comes, and if that random value is generated for all the values, is seen that where that random value falls. So I have to check that random value from whole of the population between which that random value falls. Okay, that is what I have explained in that particular lecture. So here if you see the random value, if it falls just above the zeroth cumulative sum, then the first one is to be taken. Okay, because it is on the top. So that is how the first one is taken. If that random value is greater than the cumulative sum, okay, and the next one, so I have to find j and j plus 1 wherever that needle value falls. So it is one in one part, it should be greater than that one, and so that two values between which that needle value falls is basically that. So when both this happen, okay, when both this happen, so that is the if value here. So if both of them become true, then only this will go into this. And if you say here, then the mating pool ith value of the mating pool is basically population of j plus 1th population goes into that mating pool. Okay, so that is how this is done. If you see, so that is as simple as that. You just go on checking and go on putting in the mating pool, and you return the value of mating pool. Now let us see how I have called this function, because you need to calculate the cumulative sum also. So here if you see, you have done individual pop. If you remember, from the chromosome strings you have generated individual pop, and now what I do here is for 1 to pop size, all of that I calculate the objective value for all of them. Okay, as simple as that. Just running this in loop, all the objective function values and the fitness function values are calculated. This is just for printing and seeing that it is being done or not. And then you take the sum fitness. So you just sum up the fitnesses, and it is basically sum of all the fitness values. Okay, np sum is basically, np is the library from which this sum is taken up, because it is a matrix, it is a array sum. So it takes sum up all the fitness values, and that is the fitness sum of fitness values, because you need that value to calculate the probability. Okay, fitness upon the sum fitness will be giving you the probability. And again I also declare a new set of array which is cumulative sum, and you can just see how it is calculated. So I calculate that probability of individual, each of the individual, so individual fitness value which we just calculated above, and that is divided by the sum fitness which I have calculated over here. So it gives you the fitness value for each of them put into a array form. Okay, then here you have cumulative sum is calculated again as a sum of individual population selection probabilities. Okay, and this ith one, so whatever is the sum up to this point, okay, whatever comes out to the, because in the starting it is full of zeros, so whatever is the sum up to ith one is accumulated, and that is what you have the cumulative sum. Okay, then once that is done, you have calculated the cumulative sum. Now I can call the mating pool, because you can use that function, and it takes in population value, that individual, that is whole population of array. Then you take the string lengths, okay, to why string lengths are required, okay, to write that population value in that, and the cumulative sum. So this we have just seen this function. So this is creating the mating pool, and then you print the mating pool and also print the population. So I'll write here so that we recognize that which matrix belongs to what. So I'll just write the above one, create mating pool. So we can see that a mating pool is generated and that is printed, and we will see that it is again sum of zeros and only the selected values according to the probability of their occurrence. Okay, so I can just run this one, and you can just see population size is 50. So this here it is create mating pool. So if you see in the mating pool, there will be because it is doing, so there will be several similar ones. For example, if you see here, this is not similar to this. If you see, there may be similar ones, because if you watch this and maybe this, okay, oh, they're dissimilar, so there may be similarity. I'll just take less population and run the program so that we can see this, that one which is having a higher probability is repeated several times. So what I do is I reduce the number of population, and that will give me the, so instead of 50 I'll just take say 5 population, so there is a high chance that it will be repeated. So here if you see create mating pool here, so if you see it will be repeated. Is it so? If you see, this two are exactly repeated because they may be having, so these two and the possibly the above one is same. Okay, so that is repeated because this has a higher probability of this one. So if you see also, you can just check if which one is having higher probability. So if you see, this is having probability of 0.3, this is very small, this is 0.2, and this is 0.4, is it? So this will be repeated more number of times. So fourth one, so whatever is the fourth one would be repeated many number of times over here. Okay, so I'm not going into detail this, you can just definitely write yourself and check that how this works. So this is how the mating pool is created. Thank you for now.